Welcome to the next session of Module 5. In this session, we will be dealing with the different methods used for the synthesis of nanomaterials. Commonly employed methods are sol-gel process, precipitation method, and chemical vapor deposition method. So first we'll see sol-gel process. In sol-gel process, chemical transformation of sol into gel state followed by transition into solid nanomaterial is taking place. It is widely used for the preparation of oxide material. So before we go to sol-gel process, first we should know what is sol and what is gel. Sol and gel both are colloidal solutions. Sol, it is a colloidal solution of solid particle dispersed in liquid medium. So here solid is the dispersed phase and liquid is the dispersion medium. Whereas gel, it is also a colloidal solution in which liquid particles, they will be dispersed in solid medium. Now the steps involved in sol-gel process. First step is preparation of sol. A stable colloidal solution called sol is prepared in this step. The precursors for this process consist of metal alkoxide. Precursor means the starting material. So the starting material used for this process, it is metal alkoxide. Metal alkoxide, it is represented as MOR. Here M stands for metal and OR, it stands for alkoxide. So metal alkoxide is dissolved in alcohol and then water is added, whereby hydrolysis takes place. That means breaking by water takes place, whereby this alkoxy group of metal alkoxide and the hydrogen group of water, they combine forming ROH. ROH, and this metal, it will combine with the hydroxide and form metal hydroxide. So metal hydroxide and alcohol, it will be produced in this step. Now next step is conversion of sol into gel. Here polycondensation of hydrolyzed species, it results in the formation of three-dimensional network called gel. So here the hydrolyzed species is this one, metal hydroxide. So metal hydroxide, it will undergo polycondensation. That means many condensation reactions will be taking place. So metal hydroxide, it can condense with other metal hydroxide molecules, whereby hydrogen of one metal hydroxide and the hydroxyl group of the other metal hydroxide will combine and form water, and the remaining is MOM. So MOM plus water. Since water molecule, it is released, it is called water condensation. Similarly, this metal hydroxide, it can also condense with a metal alkoxide group, whereby the alkyl group of the metal alkoxide and the hydroxyl group of the metal hydroxide, they will combine forming ROH. Since here ROH is eliminated, it is called alcohol condensation, and the remaining is MOM. So these are the steps involved in conversion of sol into gel, and the metal used, it can be either silicon, titanium, zirconium, aluminium, etc. Now next step is aging of the gel. Gel is allowed to continue polycondensation reaction until it transforms into a solid mass, and this is accompanied by contraction of gel network and expulsion of solvent from the gel pores. And aging process usually exceeds 7 days. Now fourth step is drying. In this process, water and other volatile liquids, they are removed from the gel network. If drying is carried out by thermal evaporation, gel network, it will collapse and zero gel will be formed. Zero gel, it will be an open network that is formed by the removal of solvents from the gel. If drying is performed under supercritical conditions, the product will be an aerogel. And aerogel means here the network structure it will be retained and gel with large pores may be formed. And the fifth step is dehydration. To stabilize the gel against rehydration, that is again this gel it should not absorb water from the moisture and it should not get hydrated. To avoid that, surface bound MOH groups they are removed by calcining at temperatures up to 800 degrees Celsius. So gel is heated to a temperature of 800 degrees Celsius and it is calcined to form dense ceramic or dense film. This is a nano material. So this is the sol-gel process for the synthesis of nanomaterials. Now this represents the diagrammatic representation of sol-gel process. Here the precursor solution it will be taken. Precursor solution is metal alkoxide. It is dissolved in alcohol and to that water is added whereby hydrolysis takes place. Sol thus produced it is subjected to polycondensation reaction whereby it results in the formation of gel. Gel it is then subjected to drying process. If it is done by evaporation, zero gel will be formed. If it is a supercritical drying, aerogel will be formed. The zero gel and aerogel it is calcined at 800 degrees Celsius to form the final compound. Now we'll move on to precipitation method. Here the precursor used is a metal salt, usually nitrate or acetate of the metal dissolved in water. It is used as precursor. In sol-gel process we used metal alkoxide as a precursor, whereas here in precipitation method we are using metal salt as the precursor, metal salt dissolved in water. Here acid or base it is added to adjust the precursor solution pH to a required or desired level. Then a precipitating agent is added to initiate nucleus formation. Nucleus formed, it grows into particles and it gets precipitated. Precipitate is then filtered, washed, air dried and calcined to obtain nanoparticles. This is the flow diagram. Precursor that is metal salt, usually metal nitrate or acetate. It is hydrated, that means it is dissolved in water. To that a precipitating agent is added. It results in the formation of nucleus. Nucleus formation, nucleus it will enlarge whereby supersaturation level is attained and thereby it precipitates. Precipitate it is then filtered, washed, dried and calcined to obtain nanoparticles. Now zinc sulphide nanoparticles they are produced from zinc acetate precursor using thioacetamide. Thioacetamide it is used as a precipitating agent which will provide sulphide ions. Zinc ions it will come from zinc acetate. So zinc ions it combines with the sulphide ions that is provided by the precipitating agent to form zinc sulphide precipitate. So when the concentration of the ions in the solution increases and reaches a critical level, that is supersaturation level, nucleus formation is initiated. It grows and precipitate will be formed. So this is how zinc sulphide precipitate or zinc sulphide nanoparticles they are produced using precursors zinc acetate solution and the precipitating agent thioacetamide. Now advantages, it is a simple and rapid method for the preparation of nanoparticles and particles of desired size it can be controlled by optimizing the conditions. If the rate of nucleation if it is slow, particle size will be large. If the rate of nucleation if it is rapid, particle size will be small. Thus we can get the particles of desired size by controlling or by managing the optimizing conditions. Thank you.